How do I use this information? There must be a great deal of value to this. And to that end, we've probably seen this quote. This quote has been around for a number of years. It says, "Data is the new oil." I think this is true, but I think most people misunderstand this. Most people think, hey, I'm just going to collect data, and I'm going to win because I have the data. That's just flat out not true. That isn't actually the entire quote either. So let's look at the actual quote. Data is the new oil. It's valuable, but if unrefined, it cannot really be used. It has to be changed into gas, plastic, chemicals, etc., to create a valuable entity that drives profitable activity. So must data be broken down, analyzed, for it to have value. So it's not enough just to have that data. We need to do something meaningful with it. So what does that mean? What do I need to do to the data? So let's think about what our goal is with data. It isn't to have data, it's to make better decisions. So how do I make better decisions once I have data? The first thing everyone does once they have that data is they do descriptive statistics. What does the data tell me? What happened? Who led Major League Baseball in home runs last year? Who took the most three-point shots in basketball last year? Who had the best plus-minus in the NBA last year? We can take a look at all of that. This is useful. It helps me understand what's happened, but it's telling me what has happened. I can evaluate the past. I know who's bought my tickets, but I don't know what's going to happen. If you stop at this point, I describe this as driving a car by looking in the rearview mirror. It doesn't help. So I'm not paying Harper for his last year's performance. I'm paying him for 13 years because of what I hope he's going to do in the future. Well, what does that mean? I want to go from descriptive statistics to predictive statistics. Take that data, learn from the past, and be able to use it to say not what Harper did last year, but what he's likely to do next year and for the next 13 years. But this isn't the end. This is just the start. I can now look forward and say what's going to happen, but there's a lot of variation beyond that. I don't want to just say this is what's going to happen. I actually want to be able to say what should I do about it? Not what is likely to happen, but how much should I pay for Harper? Or in a sporting context, what should I do on the field to change the behavior of my team, to change the outcome? Or how do I engage with a customer to turn them into a lifelong season ticket holder, or to encourage them to upgrade to a better season ticket package? So that's really what our goal is to get to this prescriptive analytics step. Okay, so what does it take to get there? So I've got a data science team. I have all of that data. How do I get there? I think of 5 different things I need to do to get there. The first thing is I need the data. It doesn't change. I need the data in a usable fashion. I need to know what's there. There are a lot of organizations that have a massive amount of data and don't know what they have, or they don't have it in a convenient place, or they don't have a convenient way to access it, or even worse, they have the data in multiple different places. So my season ticket team knows about the season ticket holders, but they don't know about the engagement on my app. How do I tie that together? But then the next step is to take all of that data, pull it back together, blend it. This tends to take data scientists a lot of time. Get the data ready to be used. Now I can begin building predictive models. So I build those predictive models. These will predict the various things we're thinking about. Now, a lot of data scientists at this point have historically said, well, I'm done. I built my predictive models. Well, that doesn't help me make a decision. So what am I going to do about that? So take that, and I need to deploy it. I need to put it in some framework where I can use it to make predictions on new data. So I know what has happened. Now I look at my current season ticket base. Now I can make predictions about which of these people are likely to upgrade. And then once I've gotten to that point, I can actually use it. Now it's accessible to me. Once I can use it, I've reached my goal. This is the point. This is where the money is. This is where the winning is. Consumption could be building a campaign to target the people who are likely to upgrade. It could be building a simulation engine to understand if I'm a football team, every single play against every single defense, predicting what the likely outcome is, and then trying all of those combinations to determine what is the best play against that defense in this situation to help me inform the decision-making of my coaches to give them a better sense of what's likely to occur. Now, when we think about that, we think about the various pieces. This deployment and the consumption, this is where the value is. This is where I'm trying to get to. But let's be perfectly honest, it's hard to get there. We actually are going to spend a great deal of our time in this prepping, blending, aggregation, deployment. All of these things are hard. Lots of data scientists are going to spend their time complaining about it. We need a way to speed this up. If we do data management right, if we do the analytics right, we can save a great deal of time. And so that's the goal. This needs to be done whether I use automated machine learning or I use some other technique. I do it by hand. The point of automated machine learning is to help us do this more quickly, get to that result, allow us to iterate, allow us to try various different things. So what should I do with it? What decisions should I make? So let's start on the business side of sport. So from the business side of sport, I want to drive fan engagement. I want to drive season ticket sales, individual ticket sales. I want to identify the optimal pricing for my tickets. I'd like to understand the value of my customers. Some customers are worth a lot of money to me. Maybe I want to treat them differently. I oftentimes have different types of reps for different value customers. How do I assign those customers to those reps? How do I identify the person who just bought their first 40-game season ticket package, identify that customer who I may have for the next 35 years? Maybe I treat them differently than the person who's only going to buy 10 years because they want to go to the All-Star game next year, or buy 10-game packages. But beyond that, I can help drive the business in other ways. The sports business has a relatively high attrition rate for employees. We see movement all around. Can I identify those individuals who are at high risk of leaving the organization? Maybe make some move to keep them. Is there something I can do? How do I hire? We're constantly hiring new people, bringing in new ticket reps. How do I identify the right people to hire? How do I market? What's the right message? What's the right timing? What type of message works? Are my radio advertisements working? Are my TV advertisements working? Is a banner ad working to drive additional season tickets? Now, once I have all of this information, I can take that next step. What's the right way to engage with a given customer to drive their purchase decision or their renewal decision? So how do I handle the business operation? This is really important to the sports teams. This is really important to keeping our fans coming. The other thing that's important is that we win on the field. So what sorts of things can I do? Based on past player performance, can I predict future player performance? So I'm getting ready for the NFL draft. We've got the combine happening. We're taking a huge amount of information about a lot of these players. We're going to go to the pro days. We're going to take additional information. I have scouts who'd been watching their college games. I have the stats from their college games. Can I take all of that information and make a prediction about how good that player's likely to be to allow me to rank the players? So I know if I need a defensive end in the first 3 rounds, who are the best defensive ends available to me today? Or is there a player who maybe isn't a defensive end today, but played linebacker in college, who I think will be a really good defensive end in my system going forward? So can I make decisions like that? Can I understand for existing players, should I renew a contract with an existing player? Who should I trade for if a trade opportunity comes up? What sorts of skills should I have the player work on to become more valuable and be a better performer going forward? Beyond that, can I identify injury risk? Can I identify those players who are about to get injured? Can I identify in real time those players who got injured and haven't told me yet because they don't want to come out of the game? And then I alluded to this before, if I can predict all of these things, if I can predict the result of a play, can I begin to influence game time decision making? Maybe not in real time. Maybe I can't do that because of the way technology is allowed on the sidelines. But can I influence the planning for the game? So this is our goal. So we've been talking about data science. Well, let's just hire a lot of data scientists, right? Data science is the sexiest job of the 21st century. Generally, when I talk about this with customers, my statement is, you can't hire data scientists fast enough. You have too many problems. That's still true. There's too many of these questions. I listed a huge number of questions. There's a huge amount of work. On the other hand, lots of people want to work in the sports analytics field. You can probably hire data scientists faster than Wells Fargo is going to be able to hire data scientists. They're more interested in working in sports. So this isn't quite as big of a deal, but there still are challenges. The first one is, I need a pipeline to do this. Think back to that 5-step process. I need to build that pipeline. I need to maintain that pipeline. I've built these pipelines. I've built them multiple times. And I like to say I worked on a team of 10. I built a pipeline. I handed it over to my team, and I had 15 different pipelines to maintain. So every data scientist is going to change this, make it a management headache. You also have the problem that just because one person was building amateur draft predictions doesn't mean 2 years from now they're still building those same predictions. How do I maintain continuity? And then I still have turnover. I can hire, but people move around. People change jobs. They jump between different jobs in the same sport. They even jump between sports. So how do I maintain that continuity to allow me to continue using and building these models and refining them? So we've built out that automated data pipeline. Anyone who's ever built automated systems like this know they tend to be somewhat fragile. So what's the solution? That solution is automated machine learning. I need a solution that automates the 10 steps to building the model without human instructions, but that's human-friendly, that is not a black box. So I need to pre-process the data. I need to do the feature engineering. I need to try lots of different algorithms to build the best model. I need help picking the best algorithm once I've built the model. I need to do the training and tuning with that algorithm. I should try ensembling. If I'm looking at a sports prediction, I want the best possible model, so I want to try interesting combinations of algorithms. I should be able to see how all of those things compare to one another. I should get insights out. I don't want this to be a black box. I don't want to have a model go into a draft meeting to say, hey, so-and-so is the best defensive end, and have them ask me, well, why? If I can't explain why I think they're the best defensive end, I'm not going to get anywhere. I need to be able to deploy this easily. I need to make it easy for everyone to take the results. And then finally, I should be able to monitor the results of those. So if I'm making a prediction about future player performance, a year from now, can I look back, compare what actually happened to my model to know, did my model do a good job? And if it did, can I update that, use that information to drive better model building going forward? So with a tool like this, I can now automate those 5 steps from I've got my data through I prep my data, I build my models, I deploy my models, and I can now begin using them to drive these business decisions to help me decide on the field what should I do? And then off the field, how do I engage with my fans? How do I ensure that they keep coming back, that they keep supporting the team? As decisions go against me, not everything is under my control. My team may not perform this year. I want the fans to remain engaged. I can't sign the right free agents, right? Lots of teams have this complaint when a free agent signs, well, why couldn't we have done that? But I need them to keep coming out and keep supporting the team. So how can I do that? Through automated machine learning. So with that, are there any questions about anything I've spoken about? Yes, way in the back.
So I was in a session earlier, Scott O'Neill mentioned that one of the biggest issues in our analytics is the bias that we inject in the process. So how is data robot negating or taking out biases that are included in this data science process that they're automating?
So the question was about bias in the data science process, and how do we as the individuals insert bias, and how do automated machine learning tools like Data Robot help with that bias? So I think there's multiple sources of bias in machine learning. The first source is really hard to challenge, is that these machine learning techniques are based on past data. And so if I haven't seen it happen before, it's really hard for me to project what's actually going to happen. Now, with that, we actually have seen some of this happen in multiple sports. We've seen the launch angle revolution in Major League Baseball. We've seen the change in the way relief pitchers are being used in Major League Baseball, which may be changing the results we're seeing. We are definitely seeing a change in the way we're passing and in the NFL. We're seeing the three-point revolution in basketball. Those are useful because we did see plays similar to that in the past. We should be able to infer and extrapolate that way. From a human perspective, I think what's really important is understanding, I said human insights as one of the most important things in automated machine learning, is I need the model to tell me why it's making the decision, what exactly is being done, and then we can look at it, not just I as a data scientist, but to talk to the other people in the organization to validate my model that, yes, I agree that those things driving the modeling decision make sense and doesn't have that bias. Okay? Are there other questions? Yes?
So you emphasized a couple times that kind of the entire process is automated. Are there any points at which analysts, data scientists can jump in the loop? And is it, throwing my from one end, get what I want at the other end?
Yes, so that's a good question. So we talk about automating this entire process, and the question is this a completely automated process, or do we have kind of a human-in-the-loop opportunity where the analyst can jump in? I think it's important that the analyst has insight into every step, and in many of those steps, yes, the individual analyst should have the ability to interact with it, to change the mix of models that are being tried, to change information about, well, no, we're not doing that kind of pre-processing. Yes, we're going to do that kind of pre-processing. So yeah, in an automated machine learning technique, it could be a fire and forget type solution. If I'm doing rapid iteration, that makes sense. That final model, when I've made my final decision, yes, I probably want a little more control over it, be able to make some of those decisions myself.
Can I ask also a quick follow-up? In terms of the class of models, right?
Yeah.
Implementations of different types of models, are those again predefined, or is that something?
I think all automated machine, so the question is, are the models in these sorts of solutions predefined? I think the answer is going to be yes, because an automated machine learning solution needs to know how to build the models. So it's going to have a class of algorithms that it knows about. I think the idea is to find a solution that has the broadest class that you possibly can. So maybe I like linear regressions because I like really simple explainable models. So I'm going to take that information. Maybe I'm looking for the absolute most accurate model, so I'm willing to take decision tree, gradient boosted tree type models. But I'd like to see what the trade-off is as well. So I think an automated machine learning technique should show me that. Other questions? Okay? Well, thank you very much.